Lesson 9.4, we're going to talk about series. This is the Greek letter sigma, which we're going to use a lot when we go through and calculate arithmetic and geometric series. What we're going to focus on is summation notation, which we're also going to refer to as sigma notation, sums of arithmetic and geometric sequences, infinite series, and convergence of geometric series. Okay, this is important because in the second part of calculus we go through a lot of integration which involves these series. So now we're going to talk about the pieces of summation notation. So we can also call this sigma notation because we use the Greek letter sigma. We read this as the sum of a sub k from k equals 1 to n. Okay, the k equals 1 part, that's called our lower limit. N is the upper limit. It tells us how many terms we're going to have in this series that we're going to calculate. It's called summation notation because we're adding all of these terms together to calculate the value of the series. Normally we're going to use the letter k. That's called the index of the summation. I is also a common letter we use. Technically it really doesn't matter. It just has to be some variable. We have a couple of different formulas we can use to find the sum of a finite arithmetic sequence. First, let's go through some vocabulary ideas. Finite means the sequence is going to come to an end. It has a limited number of terms. Arithmetic means that our terms are increasing by the same value each time. We're adding a common difference each time. So the two different formulas which you can see below that we're going to use simply depend on the information we have. We're going to use the first one if we know what the first term and the last term of our sequence is and the number of terms in the sequence. We would use the second one if we know what the first term is, the common difference, and the number of terms in our sequence. Okay, both of those are going to allow us to find the sum of an arithmetic sequence. Example 1, summing the terms of an arithmetic sequence. So we want to consider the series 1 plus 2 plus 3 and going to and adding all the way up until n. For part A, we want to find an explicit rule for the sum t sub n of the series. So for part A, we're looking for the sum of the series t sub n. We're going to use one of these formulas that we just talked about. I'm going to use the first one. So this is equal to n times the quantity of a sub 1 plus a sub n all divided by 2. The reason I'm using this formula is because we know what the first term and the last term are in this series. So this simplifies to n times our first term, a sub 1 is 1, a sub n is n, all divided by 2. Now if we just use some basic algebra, we can rewrite this as n times the quantity of n plus 1, all divided by 2. So this would be a rule to calculate the sum of this series. Now in part B, we're going to use this rule to find the sum of the series when we know the first term and the last term in our series. So for part B, we have t sub 100 is equal to, we're taking n, the number of terms, which is going to be 100 in this case, multiplying by our first term plus our last term and dividing by 2. And if you go through and simplify this, you are going to get 5050. So this would be the sum of the series 1 plus 2 plus 3 all the way up till 100. In this example, we have a corner section of a stadium has 6 seats along the front row. Each successive row has 3 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? Yes, we could go through and calculate because we know the pattern. If there's 6, the next one's going to have 9, 12, 15, 18, so on and so forth, and add all those together. But we're going to use this rule that we understand now about arithmetic sequences and series. First thing we need to do is calculate how many rows there are going to be. So we have to use what we learned in the last lesson. A sub n is equal to a sub 1 plus n minus 1 times d, the common difference. Okay, this was our rule to calculate the nth term in an arithmetic sequence. Now we can fill in the values we know. A sub n, we know that value is 24, that's the last row. There's 6 seats in the first row, plus, we don't know what that n value is, that's what we're looking for. But the common difference each time, if they're increasing by 3 seats each time, the common difference is 3. So now we're just going to go through, use some algebra to simplify this. We would subtract 6, so 18 is equal to 3 times n minus 1. Divide by 3, we get 6 is equal to n minus 1. Last step, add 1 to the other side, so n is equal to 7. That means there would be 7 rows going from the first one that has 6 seats to the last one that has 24 seats. So now we're going to go through and use our rule for an arithmetic series. So what we're looking for, the total number of seats in this section. So the number of seats is going to be equal to, we calculated the number of rows to be 7, times the number of seats in the first row was 6, number of seats in the last row was 24, divided by 2. 6 plus 24 is 30. 30 divided by 2 is 15. 15 times 7, there would be 105 total seats in this section. So we've discussed arithmetic series. Now we're going to discuss geometric series. So we can tell it's a geometric series if there's a common ratio between consecutive terms, if we're multiplying by the same value each time. So what you need to remember is this basic formula. We're taking a sub 1, our first term, times 1 minus r, which is a common ratio, raised to the n power, the number of terms. All of that divided by 1 minus the common ratio. Okay, so this is how we calculate the sum of a finite geometric sequence, meaning we know there's a limited number of terms. Now we're briefly going to talk about an infinite series. Basically, we could tell it's an infinite series if our upper limit is infinity. That means the number of terms is never going to end, it's going to go on and on and on. The main thing with infinite series is they either diverge or converge. If they converge, if you remember from the last lesson, that means that the limit is going to approach some value. Okay. If it diverges, that means the values are either going to continuously increase or decrease. They're never going to come to a single value or a limit. When looking at a geometric series, we could tell if it converges by looking at the common ratio. If the absolute value of the common ratio is less than 1, then the geometric series is going to converge to a single value, and we can calculate the sum of that by taking a, which is our first term, divided by 1 minus our common ratio. In this example, we want to determine whether the series converges or diverges. If it converges, then we're going to find the sum. So what we need to look at is our r value, take the absolute value of 0.25, which is less than 1. So since our common ratio has an absolute value that's less than 1, we know the series is going to converge. So now we have to use our formula to calculate the sum. The formula is going to take a, which is our first term, in this case the a value is 2, divided by 1 minus our common ratio, which is 0.25. So this is going to be equal to 2 divided by 0.75. Now we can use some algebra. This is the same as 2 over 1 divided by 0.75. We can rewrite that as 3/4. So this is going to be equal, we have a fraction divided by a fraction multiplied by the reciprocal. So 2 over 1 multiplied by 4 over 3, which will simplify to 8/3. So the sum of this geometric series would converge to a value of 8/3. In the last example, summing the terms of a geometric sequence, lower limit of 1, upper limit of 10. The initial term is 3, the common ratio is -2. So what we're going to be using is, since this is a finite geometric sequence, we're going to use this expression we referred to before. So the sum of the first 10 terms in this sequence is going to be equal to a sub 1, which is 3, times the quantity of 1 minus -2 raised to the n power, which is 10. Okay, that's all divided by 1 minus r, 1 minus a -2. Okay, normally I would tell you if you're subtracting a negative value, just change that to addition. We cannot do that in the numerator because the value we're subtracting, that -2, is raised to an exponent power. So make sure you include all of these parentheses. So if you type these in on a calculator, you should get -1023. So the sum of the first 10 terms in this geometric sequence would be -1023.